Hello, in this video, we are discussing circular time shifting property of DFT and we'll solve one example based on it. Property is circular time shifting property is if x of n is the one of the sequence and if its DFT is x of k, now we'll add time shift to this x of n. If x of n get delayed by L unit, its effect on this x of k is x of k will get multiplied with the WNLK. L is the time shift which we have added to the x of n. This is the delayed x of n. Similarly, if we advance the x of n with the L unit, its effect is x of k, your DFT will get multiplied with the WN minus LK. So for delay, it get multiplied with the WNLK, and for advance it will get multiplied with the WN minus LK. Now let's understand what do you mean by this circular time shift. We know the normal time shifting, delay, advance. What do you mean by circular time shift? See, this is your x of n. For example, the samples are 1, 2, 3, 4. Now when I will delay this by 1 unit, your sequence get shifted in a anti-clockwise direction by 1 unit. That means in case of circular time shift, your samples remain same. Only it will get shifted anti-clockwise or clockwise. For delay operation, it gets shifted to the anti-clockwise. That means x of n minus 1, that is delayed by 1 unit, one sample will get shifted here and other samples just shift one ahead. That means this 4 will come here and other 1, 2, 3 just shifted by 1 unit. Suppose one more shift will add, that is x of n minus 2. 2 shift in a anti-clockwise direction. This is first shift and then second shift. So this 3 will come here by one position and the 4, 1, 3 as it is. So like this, you can add a shift. That means when we'll shift the samples in an anti-clockwise direction, that is called as a delay. If one shift, one delay, two shift, two delay, like this, you can shift. Remember, the number of samples just get shifted. It remains same. 1, 2, 3, 4. Here also, the samples value are 1, 2, 3, 4. Just there is a shifting. Now advancing. Advancing is nothing but we are shifting the samples in a clockwise direction. So suppose this is your x of n. X of n plus 1 means we are shifting in a clockwise direction by 1 unit. So this 1 will come here and this 2 and 3 get shifted. Like this 2, 3, 4. 1 gets shifted here. So it is clockwise shifting. But if you check advancing and delay, suppose I will add one more delay to this one, x of n minus 2. Again I will add one more delay. That means this 2 I will shift by 1 unit. So I will get n minus 3. X of n minus 3 is 2, 3, 4, 1. And if we'll check this x of n minus 3 and x of n plus 1 is same. So always advancing operation is related to the delay operation. Why this happens? Because it is circular time shift. The number of samples of this sequence just get shifted. We are not including any additional value instead of this 4 sample values. That's why it is called as a circular time shift. In case of anti-clockwise direction, it is called delay. In case of clockwise direction, it is called advancing. But always advancing operation is somehow related to the delay operation because of circular time shift. So it will be easy for us to remember only one format of the delay. X of n minus L effect on the DFT is x of k get multiplied with the WNLK. To avoid our confusion, we can just remember this first relation. That is, if x of n is the sequence, if its DFT is x of k, and if we'll delay the x of n by L unit, x of n minus L, the effect on the DFT is your DFT will get multiplied with the WNLK, where L is the time shift which we have added. So we can remember only this one so that it will be easy for us while doing the calculations. Now, let's solve one example. Find the DFT of a sequence x of n is equal to 1, 2, 3, 4. And second one is using the result obtained in 1, find the DFT of a following sequence x1n is 4, 1, 2, 3 and x2n is 2, 3, 4, 1. Now, first we have to find the DFT of x of n. We already know how to find the DFT by matrix method. That's why I'm directly writing here x of k is equal to Widal factor matrix into your x of n input. Widal factor matrix, we already know how to find this value. If you don't know, please refer previous video of how to find the DFT. Now do the matrix multiplication. First row, first column. Similarly, second row, this column. Third row, this column. Fourth row, this column. And this is your matrix multiplication. And DFT is this 10 minus 2 plus 2j minus 2 minus 2 minus 2j. So this is the DFT by direct method, or we can say by matrix method. Now the second one is important. Using the result obtained in 1. That means using the DFT which we have obtained in this first, find the DFT of following x1n and x2n. Now, so to find DFT, we want to use this DFT of which we have calculated. So for that, this type of question, first check what is the relation between x of n and x1n, x of n and x2n. Then only we can use this result to find the x1k and x2k. So first, find the relation between x of n and x1n. This is our x1n whose DFT which we want to find by using the DFT of x of n. So here, first check the number of samples 4 and the content sample values 1, 2, 3, 4. Here also the sample values of 1, 2, 3, 4 but in a shifted manner. So first let's check what is the shift, how much shift is there. We'll take one anti-clockwise shift and we'll find what is x of n minus 1. X of n minus 1 is 4, 1, 2, 3 and that is nothing but our x1n. That means when we add circular delay by 1 unit in x of n, we'll get your x1n. So here we can use time shifting property, circular time shifting property to find x1k. The property is if x of n is the sequence, if its DFT is x of k, and if we delay x of n by L unit, your DFT x of k will get multiplied with W and LK, where L is the time shift which we have added. So here our x1n is x of n minus 1. That's why your DFT is x1k is x of k is get multiplied with W and L is 1, LK, L is 1, 1k. So your x1k is nothing but x of k get multiplied with W and 1k. Let's find x1k. x1k is x of k multiplied with W and 1k. This is our x of k which we have calculated by matrix method. Now let's find x1k. x1k is x of k, W n is 4, 4 point DFT, W4, 1k. Now let's put k varies from 0 to n minus 1, n is 4. So 0, 1, 2, 3. So k is equal to 0. Put this in this equation. K is 0, x1k, x10 is equal to x of 0, W4, 1, 0. So k is 0. So it becomes x of 0 is 10 and W4, 0. Then k is equal to 1. x1, 1 is equal to x of 1 and W4, 1 into 1. So x of 1 is minus 2 plus 2j. So it becomes x of 1 and W4, 1. Then k is equal to 2. It becomes x of 2, W4, 1, k is 2. So it is W4 1 into 2. That is, it becomes x of 2 is minus 2. So minus 2 W4 2. K is equal to 3. X of 3. X1 of 3 is x of 3 into W4 1 into 3. That means this is your x of 3 minus 2j and W4 3. Now to find W4 0, W4 1, W4 2, W4 3, refer the phasor diagram. We already know this. W4 0 is 1. So this 10 into 1 becomes 10. Then W4 1 is minus j. So this term get multiplied with minus j. Minus 2 minus j is plus 2j, and plus 2j into minus j is minus 2j square. J square is minus 1. That's why it becomes 2j plus 2. Similarly, W4 2 is minus 1. So minus 2 into minus 1 is 2. W4 3 is j. So minus 2j into j. It becomes minus 2j plus 2. J square is minus 1. So your x1k is 10, 2 plus 2j, then 2 and 2 minus 2j. So this is our x1k by using time shifting property. Same x to n we have to find. So find the relation between x to n and x of n. X of n is this one. So check samples are same, just it is in a shifted version. So first we'll add one shift, x of n minus 1. It is 4, 1, 4, 1, 2, 3. Shifted in an anti-clockwise direction by 1 unit. Now let's add one more shift. So x of n minus 2 is 3 will get shift here. 3, 4, 1, 2. Add one more shift. 2, 3, 4, 1. Now this 2, 3, 4, 1 is nothing but our x to n. So x to n is nothing but x of n minus 3. So here L is equal to 3 now. Time shifting property, x of n, its DFT is x of k, x of n minus L. So here L is 3, x of k, W n L k. So x to n is x of n minus 3. So our DFT becomes x of k W n 3k. So x to k is nothing but x of k W n 3k. L is, let's find x to k. X to k is x of k W n 3k. This is our x of k. So x to k is W x of k W n 3k. K varies from 0 to n minus 1 means 0, 1, 2, 3, 4. This is phasor diagram. K varies from 0, 1, 2, 3. X2 of 0, put K is equal to 0 here. X2 of 0 is x of 0, W4, 3, 0. 3 into 0. That's why it is x of 0 is 10, W4, 0. Then W4, 0 is 1. That's why it is 10. K is equal to 1. Put K is equal to 1 here. X2 of 1 is x of 1, W4, 3, 1. So 3 into 1. So W4 3 and x of 1 is this one. W4 3 is j. So it is, this becomes x2 of 1 becomes minus 2j minus 2. Then k is equal to 2. K is equal to 2. X of 2 W4 3 into 2. That is W4 6. W4 6 is minus 1. So minus 2 into minus 1 is 2. K is equal to 3. W4 3 into 3. 3 into 3 is 9. So this is x of 3 and W4 9 is minus j. So multiply minus j with this one. You will get 2j minus 2. So x2 of k is 10 minus 2 minus 2j, 2 and minus 2 plus 2j. So this is how we can find DFT by using time shifting property. Thank you.